There's a second pair, the non-adjacent angles. So angles 1 and 3, or angles 2 and 4. And these non-adjacent angle pairs are called vertical angles. Okay, and vertical angles are a pair of non-adjacent angles that are formed when two lines intersect. And does anybody know what the relationship is between vertical angles? Oh, they're congruent. So this would mean that measure of angle 1 and measure of angle 3 are equal. Or in this case, measure of angle 2 is equal to measure of angle 4. Okay, so what we see here is that vertical angles are equal. Right, this right here, at this stage, is a conjecture. Okay, this relationship is based on definition. Okay, the definition of a linear pair is they form a straight angle, therefore they add up to 180 degrees. Okay, but the vertical angle relationship is a conjecture until we prove formally that that relationship holds true. Okay, and that's what we're going to do here in just on this next slide. Are there any questions on this difference between vertical angles and linear pair? Okay, so let's formally prove this relationship so we can then use it in any future proofs. All right, if we take a pair of intersecting lines, okay, so as far as our proof goes, all that we're given is two lines intersect. And we want to prove that the vertical angles are equal. Okay? So now, as far as the structure of a proof goes, okay, this statement, this end state, is a conjecture, meaning it's a prediction until we prove it. Okay, so let's go through our steps of formally proving this relationship. Okay, now, first thing we're going to do is just copy down our givens exactly as they appear. Okay, so two lines intersect. And even if there's nothing to interpret from that, you're still going to write it down as your first step. Okay, the next thing we need to do is, again, interpret that if we can. There's nothing to interpret, so let's introduce our end state element. So what relationship do we know about angle 1? We want to introduce angle 1 into this. Angle 1 is a linear pair with what other angle? Measure of angle 1 is a linear pair with angle 2. Therefore, they add up to 180 degrees. Anytime you use this statement in a proof, you can justify it by either saying definition of linear pair, which is what I'll generally use, or you can specifically write out the relationship. You could have also said a linear pair adds up to 180. Okay, but that introduces the element measure of angle 1. We also need to have a measure of angle 3 introduced. So if we start with measure of angle 3, what is angle 3 a linear pair with? Either 4 or 2, right? Are either of those already introduced in our proof? The 2 is already in there. So let's use that pair. So we have this pair. Let's also introduce angle 3 plus angle 2 is equal to 180. For the same reason, it's also a linear pair, so by definition, they add up to 180. Okay, again, you want to introduce as few elements as possible. So if we had done angle 4, it wouldn't have helped us. We want it in terms of the fewest terms as possible. All right, so now we have these two things that are set equal to the same thing. And what do we know? Two things. So this equation and this equation are two things that are equal to the same thing. So what do we know about the relationship between each other? They're equal, right? Angle 1 plus angle 2 is going to equal angle 3 plus angle 2. And if two things equal to the same thing are equal to each other, is an example of transitive property. Right? Or substitution, again, what we could have thought of is we took this first equation from step 2 and just replaced 180 with its equivalent, angle 3 plus angle 2. All right, once we get to this step, we can make one last manipulation. And in order to get angle 1 completely alone by itself, what would we need to remove from the left side? We remove angle 2 from the left side. We'd have to remove its equivalent from the right. And so we can either remove angle 2 or its equivalent. Well, angle 2 is there. So if we subtract angle 2 from both sides of that equation, we're left with angle 1 is equal to angle 3. And the operation we performed was just subtraction property. And we wound up with our final statement. So the final statement, we are able to show in these 4 steps here that this relationship, vertical angles are equal, is always going to be true. So now, once you create a formal proof of something, it becomes a theorem. Right? And theorems are able to be used in future proofs. Right? If you look theorems up, or if you guys to if you've had exposure to the geometry before, theorems are often numbered. We're not going to number them in this case. They're often numbered based on the chapter they fall in and then the number which theorem it is. So this would be considered theorem 3.1, chapter 3, the first theorem that we've come up with. But I don't want you to remember them as numbers. Just remember them as phrases or relationships. So this first theorem, once we show this, is vertical angles are equal. And anytime you want to use this in a proof, the way that you're going to do that is you can simply use the letter VA. Okay? VA stands for vertical angles are equal, and so that simple abbreviation can justify that statement in any other proof that comes along.